Today's episode of the Occasional Podcast is brought to you by Zoo Audio, waging a revolution in American hi-fi since 2000. Zoo's responsive, highly efficient loudspeakers pack massive tone and shove to bring recorded music to life like never before. And Zoo cables bring the same. Check out the Union 6 and Union 6 Supreme and get a first look at the upcoming Definition 6 at ZUAUDIO.com. That's ZUAUDIO.com. Today's episode is brought to you by Expona 2023. America's largest high-fidelity audio show takes place April 14th, 15th, and 16th at the Renaissance Schaumburg Hotel and Convention Center near Chicago, Illinois. Plan a trip to the Windy City this spring and sample over 190 listening rooms of high-end audio equipment. And explore the latest in headphone hi-fi and Expona's Ear Gear Expo. Tickets are available now at AXPONAdotCOM. That's www.AXPONA.com. Hey everybody, thanks again for joining us. The Occasional Podcast, you have reached us, and today my illustrious guest is Garth Powell of Audioquest. Thank you so much for joining us.
Thank you, Brad.
And it's always a pleasure to have him on. This is actually his second time on the show, and if you guys want to check out the earlier episode, we went through a lot of subjects, and I'm excited to have him back on the show because I got to tell you, I've done probably 150 of these episodes, and the one that we did really stands out in my mind as a very informal, exciting, and just a guy who's really thinking about not just his role, but the space as a whole. He thinks about things as a space and whole. Garth, I don't mean to talk about you in the third person while you're here on the show, but you did such a great job, and you seem so aware of the things that are going on and the things that can be. You're not just pigeonholed into whatever your particular function is. But what do you think are the most important talking points when we talk about noise and hum in an audio system? I think a lot of people might realize when they start toying around with the audio systems that they put their head close to a tweeter. You might find no matter how hard you try, there's a little bit of hiss. I think the dreaded thing we all hope we don't get is a single tone in the mid to low region that just keeps going and you can't get rid of no matter what you want. But also, and I was hoping you could address the difference between this noise and hum. What about digital interference, or what kind of things that are kind of noise that we don't even recognize right off the bat that are outside interference and these type of things? So maybe we could kick it off with some of the definitions that you have for either of those ideas.
Well, the answer to all of that, or the summation of everything that you just brought up, Brian, is essentially yes. All of those things are real. All of those things are problem. But the misconception that I think a lot of people have, and the problem, I think, with aspects of our industry, and I see this on the internet constantly, and even with a lot of manufacturers going back many, many, many decades, some before I was born, and a lot of the, even the engineering papers and everything like that, they're all assembled together. They're all smushed together as one, and they absolutely positively are not. Most of them have nothing to do with each other. They are all under the category of, parasitic sounds, parasitic signals that you don't want, things you want to get rid of, things that are creating problems in your system, things that are creating a masking effect, that are, like robbing you of low-level information because that noise, creates a masking effect, and it's essentially like a veil, or like I'm covering my mouth with my hand.
Right.
I want this. Mm-hmm. So so that's important. but it's dealing with it. Because, for example, if you're talking about, hum, well, if you're in parts of the world that, typically have on average 230 volts, that's likely a 50 hertz source. So that's going to be 50 hertz hum, but also sometimes you're going to hear the harmonics above that up to the fifth harmonic. If it's, North America and a lot of the 100 to 120 volt typical countries, it's going to be 60 hertz or 60 cycles per second. And so you're going to hear that frequency, or you're going to hear, once again, up to about the fifth harmonic above it and so forth. But that's definitely going to be a nuance. Now, the thing about that is that people will imagine, because, I'm known for things like the PowerQuest and the Niagara series at AudioQuest, and our power cables and everything, like, along with our founder Bill Lowe, and the other people that I work with in our product development team and things like that. They're all very talented and work very, very hard, great individuals. And then, prior to that, this last 10 and a half years or so, I was with, Furman Sound, broadcast and pro audio for 16 years. So I've an analog engineer. I can design anything from condenser microphone to a loudspeaker and everything in between, but I'm mostly known for power and then cables these days too. But essentially what you're dealing with hum typically is a ground loop. And with ground loops, people will want to believe that, like, oh, well, there must be an accessory I can buy. There's this little, teeny, a thing that can go on the end of my, XLR or my RCA or something like that. And it's usually got a little Zener diode in it or something like that. And that's going to get rid of my hum. Wow. And I can get it on Amazon and it's cheap and it's small. Sign me up. This is great. My problems are over. Or, it becomes a situation of like, oh, well, these boxes that you design, they're kind of expensive. But if I can know that I'm never going to get a hum again, let's buy that and that problem's going to go away. Well, not necessarily. Now, every once in a while I'll hear from somebody like, hey, I plugged in your box and the hum went away. It did everything it was promised to do. Actually, I never promised it would do that. And we got lucky. Then there's reasons we got lucky that I can get into. But basically, there's different reasons for hum, but usually what you're dealing with, at least in the power domain, is a problem, with the difference or differential between neutral and ground, and and a difference, throughout the system. It's an imbalance, per se, and eventually you just end up with these circulating ground currents, and they end up, being once they are strong, they're always actually there. If you've got even like a minor ground loop, and they're always robbing you of some of the low-level detail, you can measure them with a spectrum analyzer, you can measure them with an oscilloscope, but maybe you can't hear it yet. Maybe you're not seeing your woofer, exercise itself vigorously. But when it gets really bad from across the room, you're hearing, yeah, and that's a bad ground loop. We need to get rid of that. Usually what's involved there is some combination of ground strapping. You've got something, that, you see particularly where people will take something from the pro audio world into the audiophile 2-channel world or custom install world. And this part uses unbalanced RCAs, but this part, uses XLRs, and you can buy an adapter cable really easily. But unfortunately, what also comes along with that about 20% of the time is boom. And so now, do I lift pin 1, on the on the connector? Do I need to strap pin 3 to pin 1? Do I need to get a ground wire, such as our ground goodie, but you could use any wire just to experiment with it. You don't need anything expensive to do the experiment, from this chassis and bring it over here with some piece of electronics. Let's say everything is balanced using XLR balanced cables, but the preamplifier and the amplifier in question, for example, also have RCA outs. Well, the XLRs typically are a floating system, but the RCAs typically are not. So sometimes if you take a channel that you're not even using or not planning to use, and you just one channel only, you don't even need both, you run a RCA cable from one to the next or something like that, that's another ground strap that can work to where you don't have to find a wire from this part of chassis screw to this part of the chassis screw. Sometimes that works, sometimes it doesn't, but it's in the experimental arsenal. Another thing that frequently can be tried, and this is true with certain subwoofers and powered subwoofers. I basically mean there, and so forth. There's all kinds of different ways you can get this. There's other things that can be tried, like particularly in North America, cheater plugs, which is just that thing you get at the electrical supply, your local hardware store, and the little molded piece. It's usually $1 or $2, where the ground pin disappears. Now, ideally, I hate to use it, but I never go to a client's place where we know we have a ground loop issue where I don't have a few of those in my toolbox, because sometimes you can trace a problem or you just have no choice. And in a situation like that, you usually are not going to, what you don't want to do is take your ground bar, your AC strip, or your power conditioner, your power regenerator, and float that. What you want to do is you want to go to each one of your source components one at a time and try to isolate each one of them and see if that helps. And anyone that will say, oh, you've got hum in your system, everything like that, I've got the product for you, I've got the single solution, done. I run. It's never that easy. It always takes a little bit of experimentation. But the first thing you do is you very methodically, one variable at a time, start trying some of these experiments. And I'm a big believer in. I've had so many clients for over 20 years say, "What can I buy?" Right now, nothing. I want you to invest in some cheater plugs. That's going to be a whopping $3. Like some basic hookup wire for ground strapping if you don't already have some stuff and everything like that. And we're going to methodically go through this list of things to try to solve the problem. Once I know what solved the problem, then we can start talking about how to refine and get performance better within those parameters. But first, let's get rid of the problem. And that's one of the things that you're always going to run into where you've got the hum. That's going on. There's other things that can cause hum with, like circuits that are going bad and things like that too. Let's say you've got a vacuum tube or valve amplifier, and it's a push-pull. It doesn't matter if it's a guitar or a bass amplifier or an audiophile amplifier. And the thing about this one that's unusual is I didn't have any hum, and then all of a sudden I used this thing for about 2-3 years, and I've got this hum, and I've tried different strappings, I've tried your cheater plugs, I've tried all kinds of tricks, and I just can't make it go away. And my next question is oh, you got a valve amplifier. Okay, tell me the model. Okay, yeah, that's a differential, that's a push-pull output stage, which is the most common if you're going to have a lot of output power. Okay, so my next question, then is that have you biased up those output tubes in a while? Huh? If I hear huh next, that tells me we probably need to replace those tubes, because the way that system works is they're depending on those tubes having a phase cancellation circuit of better than 100 decibels that makes sure that all the hum that circuit should be getting from the power transformer that is inches or centimeters away. It should be nothing but hum. But because push-pull is automatically canceling of 50 and 60 hertz really, really successfully, it works beautifully, except when one of the two tubes is no longer matched because it's starting to go away. Once it starts to go away, that noise canceling, just like noise canceling headphones, doesn't work anymore. And your hum's going to, come up exponentially.
Very interesting. I had not heard that before. In all my years. Thank God I don't have it. I haven't had too many hum issues there, but that's very, very interesting. What about noise then?
So that's a type of noise, but that's specifically, 50, 60 cycle hum and the harmonics above. Mm-hmm. Then you've got that thing you were talking about earlier where you go up, you put your ear right by the tweeter and you're hearing tss. Mm-hmm. Okay, that's typically self noise. The fact of the matter is that there is no such thing as perfect electronics, with the exception of every premium audiophile brand that has made perfect electronics if only people would buy and appreciate them. But those ones accepted, the truth of the matter is that we live in a real world on planet Earth, and there is no such thing as electronics that are perfectly silent. It can't be done. And even when I see, like the specifications and magazines like Stereophile and, John Atkinson for years, and put it through the Audio Precision and everything like that. No, this has got really, really good specs and, but even when they do that, oftentimes it's all, like what's called weighted response versus unweighted or, and so it's somewhat bandwidth limited and everything like that. And to be fair, it's not that anybody's trying to be dishonest in any way. It's just that you have to come up with standards that are reasonable and repeatable and that everybody in the industry can use to make it worthwhile on a comparative basis, and also just to make things manufacturable. Because everybody that's, engineer to engineer, we all know everything's a million compromises. Nothing will ever be perfect. It just can't be. You just keep striving to get better and better. And chip away at the problems, because that's always worthwhile. But but perfection, that's elusive. It's not really going to happen if you're honest. It happens every day in marketing, but in engineering, not so much. All right. So the thing of it is that you have the self noise, and that's just the intrinsic noise within the circuit, and so that a little bit of that's always going to be there, but some of that can be amplified and exaggerated by other types of induced noise that are coming in via the power, or or that are being induced via radio waves and so forth that are modulating the signal and modulating those circuits. So there are ways to bring your self noise down. I mean, the first power conditioner I ever tried and brought home from my my former employer Furman, on an oscilloscope and on a good lab bench. There were numerous times that we would bring those things into individual systems or into recording studios or broadcast facilities. We would regularly see that hiss and that self noise go down never less than 18 decibels. That's a lot. That's a big, big deal, because what you got to understand is if I got a recording that I'm listening to that's got 90 dB of dynamic range, you got to understand what's down in the weeds. That last 18 dB, that's going to be most of your extreme high frequencies. That's going to be the majority of your reverb tails. That's going to be the air, around those instruments. That's going to be a lot of your imaging. That's going to be a lot of your harmonic and your upper harmonic structure. The only reason you can tell the difference between, like a Youngchang or a Kawai, like grand piano versus a Homburg Steinway, F minor 7 is going to be F minor 7 adjusted for volume on both those instruments, folks. Through a spectrum analyzer, if you look at the highest, like a decibel waveforms, there ain't going to be a hell of a lot of difference. If you look at stuff that's 40, 60, 80 decibels below zero, like on your plot, that's where those two pianos don't look like they're in the same universe. And that's where our ear is going to. We almost ignore the loud part to key on to the soft part, because the soft part's where that magic is. Well, if you've got a bunch of noise that's coming in, self noise in this case, that's modulating that. It's just so clear. Well, I'm covering up my mouth, and I don't want this. I want this. I want to take that veil away. All right. So that's one thing.
I love the idea of that somehow interfering with the imaging, because when I hear perfect, crisp lined outside of vocals, so at an audio show, I'm always like, I want that. But it is so special and it feels exceptionally fragile. Not what you're hearing, but the imaginary border around the object, that type of imaging and just really solid focus. When everything comes together, there's nothing between. It just feels infinitely fragile. And I love that you bring that up, because
it is, because it's the lowest in level. And that's the thing that's going to get clobbered first. You're dead on. And that's the whole thing. The lower the signal level, the more fragile it's going to be. The whole debate between analog and digital. Analog would be over with if all we ever listened to was slam limited material, because all the stuff that people kind of like have a jaundiced view of analog about. Well, people just like that warm sound. They just like that distortion. That they just like that colored sound. They like that kind of old vibe. No, I like resolution, folks, and I know where and how to get it. But the thing is that it's application. Because if I'm going to compress and limit to the point where I've only got 10 or 15 dB of dynamic range, or slam limited, where sometimes I've only got 3 to 5. In a situation like that, the difference between really good high resolution digital and analog, I might as well go with digital. Digital is probably going to be a more accurate and a better result. However, if I'm going to try to do acoustic music and I'm going to try to have 70 dB of dynamic range, 90 dB of dynamic range or more, the best analog is going to kill digital, because that's where digital is no longer 24 bits. That's where it's down to a bit. That's where it's struggling. Analog's the reciprocal. It struggles as you get louder. They're both wrong. It's like it's application. Like what tool do I need in my arsenal for application? I use them both.
I love that. They're both wrong. It's not that they're both right. They're both wrong in this case, but yeah.
Yeah. So where the noise is concerned, there's that, and that's why it's so important. And then the third type of noise. Well, there's more than this, but generally there's three. There's the hum. There's the self noise, and then there's the induced noise. And the induced noise is the insidious noise. And it's like I just recently got like my blood pressure tested and everything like that because I didn't get to see a doctor during the pandemic and everything like that. And, when they were looking at my numbers and everything like that, and they were just like warning me and everything like that. We got to work on that blood pressure and everything like that. Like I'm like high level A++ OCD. Like my blood pressure is a little elevated. Like no kidding. So. At any rate, and I'm 60, so I mean it's genetic in my family. It's going to happen. And put you on, a diuretic. Okay, we'll be fine. But the thing of it is that but they were talking about like the silent killer because I'm also an outdoor cyclist and everything like that. My cardio, like vascular system's everything. So all the usual indications of like like stabbing pain up and down my like left arm and everything like that. No, none of that's ever going to happen. Their whole thing like, well, with you're never going to get a warning. Just one day you're going to get a brain aneurysm and you're done. So like you're going to want to watch this. And so just like I know that things just kind of like took a pretty dark turn, but I can laugh at it. So it's just me, folks, not you. So anyhow, the thing of it is that that whole phrase of theirs, like it's the silent killer. So the thing is that induced radio frequency noise to me for high resolution audio is the silent killer. Okay. Because it's the noise that you don't hear at the tweeter. It's the hum that isn't coming out of the woofer. It's noise that you will never be aware of in and of itself until you experience your audio files, whatever software you happen to be using, until you experience that massively reduced or have it go away, and all of a sudden you realize, oh my God, the room, that this was recorded in is much bigger than I realized. It's deeper. It's wider. This space around each instrument is more palpable. The vocalist's mouth is precisely 3 inches in diameter, not, like a circus, like effect size of like 10 by 10. The double bass player, I can tell precisely where his two hands
were.
Yeah. Everything is coming just perfectly into focus. That information is, again, low in signal level. And when noise is masking that, that's a problem. But also, equally important, and I think I probably touched on this last time we talked, but it's a thing that I just never can let go of. There would also be a kind of like thought of like, well, anything you do to reduce, some of that noise is going to get us closer to, the resolution, get us closer to the musical truth, and all that's a very, very good philosophy. That's a good point. But equally important to me is that when you're dealing with that type of noise, also really the self noise too, because it's kind of like the way you address it is one and the same. You not only want to lower all that, but you want to lower all of that over a massively wide range of frequencies, because with radio-induced noise, you're talking about the bottom of the AM band all the way up to cellular towers and above. Then you also have all of your noise, particularly asymmetrical differential noise that you're going to get from all your appliances. That's going to take you down to at least 2,000 hertz. So it's over 23 octaves. It's a mess, and you're going to need to do this as linearly or evenly as consistently as possible. And that's impossible to do, but the closer you get to it, the better off you're going to be. Like I'm hearing from time to time that we know the magic secret of the precise frequencies of interest that are going to give you that magic that your system so richly deserves. With this special technology, we can find that very specific problem and eliminate it from your system. It's a nice marketing, pitch. Nothing can be further from the truth. And the problem is that I don't care about any particular frequency of interest. There were a lot of years that even back in my Furman days where I had, outputs in my power products for digital versus analog, I don't do it anymore. I might separate them if I've got isolation, but I don't treat digitally any differently than I treat analog because it's the exact same problem. I treat a power amplifier differently because that's variable current, and I've got issues with current compression and things there. I need to worry about its power supply. I want to actually give it a current reservoir if I can. I talked about that before, I'm sure. But, like essentially, there's a way in which everything is sort of the same problem. Another thing you get into with noise, too, is people kind of like argue about, well, okay, I guess I understand all of this with analog, but, coming from the digital domain and I'm just dealing with packets of information and zeros and ones and everything like that, how in the hell can any of this make any difference? Even if I've heard this in some audio demonstration, it just seems like black magic. How can this work? Well, we can get into things like jitter, where it's like, yeah, the packets of information all came over, but they come over in the right timing sequence. That's one part. And how hard are we stepping on, correction circuits and so forth. But even more than that, here's the real problem. So far, and really going into the future that I can basically see, there is no such thing as a purely digital system. At some point, we have to turn some part of it into analog. This is going to be a problem because if we're going from one component to another component to another component to another component that have conductive chassis, that have conductive parts, that have conductive cables in whole or in part. The problem there is that, noise in theory isn't changing, the zero and ones, and maybe it's not even, creating much jitter, depending on how stable the circuits are and everything like that, and how good the word clocks are and everything else like that. But the induced radio frequency noise is coming along with that signal for the ride. And by the way, that 0 and 1 digital signal is an analog signal that's carrying zeros and ones. So it's subject to all the same problems as analog, ultimately. And it's a carrier of all that induced noise. At some point, that signal is going to reach a D to A, digital to analog converter. And once it hits the analog stage, all bets are off. All that Trojan horse of noise that came in, no skin effect. And again, I don't want this. I want this.
Today's episode is brought to you by one of the originals in high-end audio, Purist Audio Design. Purist Audio Design is proud to announce their brand new Diamond Revision. It's brand new. Re-engineered from the ground up for improved audio quality, the Diamond Revision features the clarity of diamonds, with a sound as articulate, dimensional, deep, and delicate as those stunning stones. With the Diamond Edition, experience deep bass, more microdynamics, macrodynamics, and an extended top end. For over 35 years, Purist Audio Design has connected you to the music. They passionately make high-end, handcrafted audio cables designed specifically to the needs of your system. They list their specs, such as resistance and shield quality, and you can find them at PURISTAUDIODESIGN.com. Purist Audio Design is veteran-owned and available worldwide. Today's episode of the Occasional Podcast is sponsored by INNUOS. INNUOS engineers innovative, artful, hi-fi products that deliver unexpected warmth and accuracy. Products that unleash the full potential of digital music playback. Going beyond simple ones and zeros, INNUOS products elevate music enjoyment by offering true audiophile performance from your digital music library or hi-fi streaming service. Find an INNUOS dealer near you to hear the difference. I think you had brought this up in a couple of the demos that we've seen, that in recent years, with all the Wi-Fi and all the cell phone usage and all of the stuff, this particular problem is something that maybe didn't exist at least in intensity 30, 40 years ago. There's more and more stuff. There's more and more different types, right? New types, different types, or intensely problematic types of interference that fly through the air and then can influence these things in different ways.
That's exactly true, Brian. So the problem has been twofold. One, that, like you say, there's more than ever before. And the second is that as we've added to our radio frequency noise in order to get the convenience and the new technologies and the products we all need, know, and enjoy, they have to, you have a fairly full radio bandwidth, because it's not like we decided that we were going to have cell towers and everything like that, and then we, basically created a bargain of like, okay, well, AM radio has to go. Well, terrestrial FM radio has to go.
You're done, AM. Why don't you sound more like FM, you jerk?
Yeah, exactly. That didn't really happen. Everything that was already there is still there, and now we just have to add to it. So if you're going to add to it, how are you going to do it? Well, and this isn't the only reason they did it. Sometimes it has also to do with the peculiarities of transmission and so forth. But mostly they just keep going up in frequency. Well, going up in frequency and starting to get like from the edges of the megahertz bandwidth up to the gigahertz bandwidth. The problem is that as you get into higher and higher frequencies, the original bandwidth coming from the transmitter might be a fairly large signal, but the frequency of interest, like what is the size of that sine tone, in physics, as a parasitic noise signal really matters. And this is the part that everybody misses, because it's a situation where if I've got something that's in the AM radio bandwidth and everything like that, that can still do a lot of damage. But the technology that we had back when I was a child, a nice metal chassis around my circuit, nice shielded cables and so forth and everything like that, that was probably going to be good enough. And by the time I was starting to apprentice with different broadcast engineers in the, like mid to late 70s and so forth as a kid, like grabbing them, like donuts, coffees, and, and sandwiches, and, like getting screamed at, and building, preamplifiers out of spare parts, like late into the evening and everything like that. It was a situation where I had access to these just state of the art, like oscilloscopes and so forth, and, frequency counters and so forth, and spectrum analyzers when those came out and everything. And we would measure, like the power at that broadcast station. And absolutely at a critical frequency, area for audio, I mean, female vocal, for God's sakes, piano, guitar, 3,000 hertz, for example, like lower presence region. At a frequency like that, you wouldn't have seen a millivolt of noise, like in 1977. There's no personal computers yet. There's no server rooms yet. There was still all kinds of noise, but it was something you could negotiate. It was something you could deal with relatively simple, affordable, small technologies. Still needed to be dealt with on a professional level, but it was easier to deal with. By the time we were 20 years down the road, and every business has got a server room, and everybody's got a personal computer, and there's multiples in everyone's home or anything like that, if I've got an AC outlet that's anywhere near a server room, I probably got, at that frequency, 3 volts of noise. Well, 0 dBu output is 0.775 volts. If the power supplies and if the circuits that we use weren't as fantastically, magnificently designed as they are, we wouldn't have a signal-to-noise ratio. We'd have a noise-to-signal ratio. We'd be straining to hear the music underneath all the noise. So they're doing a good job. They just can't get it all because it's just too much. You got to attack this in every level that you can. I'm constantly making strides to make my technologies and my products better, make the cables better. Anything I can do to defeat noise, I'm going to do it because I'm always behind the 8 ball. It's never going to be enough. And the thing about these higher frequencies is the waveform is smaller. I'm going to circle back to that. If you're talking about, like about 30 hertz coming off of a pipe organ, or if you're talking about the, like a low E on a double bass or something like that, you're talking about a sine wave that is, like across your bedroom or bigger, depending on which one of those frequencies. If you're talking about the so-called end of audibility, 20 kilohertz, you're talking about approximately, 3/4 of an inch, or about, like 20 millimeters. Well, if you're talking about a gigahertz, like cell tower, Bluetooth, and so forth, you could put 200 of those sine waves end to end and stack them on the edge of your business card. So now the problem becomes, how is your steel chassis or your aluminum chassis, how is your standard shield on your cable ever going to be enough? Because an induced noise signal that small, it's just going to capacitively couple right past that shield right into your main conductor, like it doesn't exist. So so we're having to come up with different ways of dissipating that, and then different ways of draining that away than we ever did before. And you got to assault it everywhere that you can, because it's done great things for us as a society generally. The technologies have been amazing. No one wants to live without their smartphone. Yeah. But we've given up, like a lot, like even though we've gained. And you just have to, like pay attention to all of these things if we're going to get these things. But so many people will kind of like, you were talking earlier about recording and misconceptions and everything like that. And I'll tell you a misconception that a lot of people in the recording industry, not audiophiles, but the recording industry have, is that they go to like something like the Audio Engineering Society functions. They, for years, had these in San Francisco, and then they would have them over in New York in the Javits Center. And there's all the boutique microphones where, they're, basically trying to recreate the best and the best of, the early vacuum tube or valve condenser microphones. And there's some great vendors, and there's other ones that have tried to figure out how to do it less expensively so that everyone could afford one. And it doesn't cost 20 grand, but, and everything in between and so forth. But when they have these shootouts between the best of the best ones and then getting the best surviving old ones that are sometimes 50, 60, 70 years old and comparing, and everybody just sort of like, oh, how did they get that sound then? How did they do it? And everyone's got different theories about, well, the valves from that period, well, like the condenser from that period, well, the way this was made, and all those things are true. But the thing that no one ever really talks about is, you have an idea how squeaky clean your power was then compared to now? Can't treat it the same way.
Oh, that's such a heartbreaker right there for me.
You better not be doing that now, because the thing is that if you're talking about a condenser microphone, that's, like its zero output level is equivalent -40 dBu. If you've got a ribbon, now you're talking about -70. So they're just sitting there living in the weeds of noise. So, but at least with the ribbon, you're not dealing with its own power supply, but that preamplifier, that mic preamp better be clean as a whistle, and that better be going into good power. If you're talking about your condenser microphone, that power supply and that, like a mic preamp better be going into the cleanest power possible, because they have the same problem that audiophiles are going to have with a moving coil cartridge. Moving coil cartridge is going to be 65, dBu down. And then you've got dynamic range, which means that I've got to be clean at practically a microvolt. And then if you've got a super low output moving coil, that only, like 4 or 5 preamplifiers in the world can really do clean, or you have a step-up transformer or something like that, that can work fine. But again, man, you're talking about a noise liability and a half, and it's a testament to how great that technology is that you can still hear how magnificently resolving some of those cartridges are, considering how in the weeds the noise is. But this is also why when you were talking about self noise before, and I hear some hiss coming from the tweeters, that's dealing with a system where all the volume knobs are turned up and you're listening to line level. Try this with like with a turntable with a moving coil cartridge or something like that, and max every volume level and everything. Oh, you're going to get hum. You're going to shh. I've heard at some clients local FM station coming through because because it's trying to amplify so much. And in some instances and everything like that, depending on the circuit's input impedance and a lot of other situations, it's just a torture test. And there's some things you can do, and there's some things you just realistically can't. But what is always true is that anything you can do to bring all the noise down as evenly and consistently as you can, you're going to be better off, regardless. Digital-based system, streaming, like phono-based, tape-based, makes no difference. It's all, essentially the same where that's concerned.
I've been thinking that same thing myself lately, Garth, because on the TikTok, I'm getting these microphone comparisons, and they'll have the classic. They'll have exactly what you're saying. The copy that's like now that says we got it and whatever. And more than once, they had the Neumann, and then what is the classic Neumann number that everybody like aspires to?
U47 for vocal, and also a lot of instruments too.
But don't they have a special one at Capitol? I think it's like a special 48 maybe or something that old Blue Eyes used to sing it to.
U47 or U48, those were, and the U48 I think had like a couple of different polar patterns, but essentially it's pretty much the same circuit, and it's the same period.
Yeah, so I see the 47 though out there, and they'll.
Oh, and I was thinking for classical, yeah, that's right, M49 and M50. The 49's the cardioid, the 50's the Omni. Yeah.
But the thing that's interesting is they'll compare it to the new ones, and I'm like, it's good, but this other one didn't sound too much different. And they let everybody argue, battle it out in the comments, and everybody has different opinions. But I was thinking this very thing. I was thinking exactly what you're saying is that there was less. And what if, because there was less, they actually got more? And now maybe it doesn't hold up as well. You know, it's just...
No, they did. To get back where they were at that time, during that kind of like classic magic age, you know, like a lot of the best classical recordings, a lot of the best jazz recordings, you know, like the beginning of the stereo period, about 1958 to about 1964. The other thing that's magical about the recordings from that period is that the miking techniques and the recording techniques were high level, and everybody was listening. There was an engineer really carefully. Why? Because they had no choice. Everything was real simple because nobody had 12 tracks, 24 tracks, 48 tracks, 100 tracks to work with. Nobody had the processing power. Nobody had the ability to edit like we do now. You know, like compression, you could, unlimiting, you could do a little bit. Anything more than that, it was obviously going to be, you know, like bad, and you didn't want it. It was going to sound dreadful. The things didn't work. EQ was real subtle, mostly passive. You know, like surgical EQ, you know, with high Q, you know, like parametric and everything like that, doesn't exist yet. All the things that an engineer has taken for granted for the last 40, you know, like 50 years in that classic period doesn't exist. But because the electronics and the circuits and those microphones and those tape machines from that period are so simple, but yet so elegantly good, my God, the resolving power from some of those recordings is ridiculous. That's why audiophiles will always love them.
What year do you think that technology kind of evolved like that? Where do you think that we turned a page and they were like, oh, now we've worked out some of the kinks and we have full resolution, or we have just the higher dynamic range? And because I feel like if you really listen to the span of, let's just say, the Beatles across that short span of years they made music, you can start to see progress from a board that only has, like, I think they mentioned a left and right switch for some of the stereo.
Left, right, center.
Yeah. And then we evolved to obviously more kind of just like, I've heard some tape Beatles, generally speaking, at the MBL room with United Home Audio at the shows, where he brings in some Beatles stuff. And I keep thinking about that every time you're speaking about this era where you hear it's fully analog, and it is just the experience is just like something was special, right? It was there. Like everything you're saying is they had something going on where the sound quality wasn't abysmal. It wasn't fuzzy. It was, as it went to the recording device, pretty damn good considering what they had to work with.
Actually, I kind of see it in a slightly different way. If you were only talking about a classical orchestra, if you're only talking about a grand piano, you know, concerto, if you're only, or, you know, solo, if you're only talking about, you know, like a jazz combo, folk instrumentalists or something along those lines, something that's relatively simple, not pushing the volume spectrum too terribly much, you know, like in terms of electronics or anything like that. If you're talking about that, the truth of the matter is that there's a real argument to be made that we didn't necessarily progress much past about 64, you know, which is like 2 years after I'm born, barely. I mean, it's because I'm late 62. The fact of the matter is that stuff was unbelievably resolving and unbelievably good. Where it really sucked and fell flat on its face was R&B and rock. Because again, it's kind of my comment earlier about playing for the room, playing for the studio, playing for the gear. That gear had been exclusively made for classical music, if you were honest about it. And so, you know, and all the techniques that everybody had and all those studios and the way everything was set up for that. That was the bias. That was serious music. You know, like rock was a 2-year fad that was going to go away soon. So, you know, that's how everybody in management at every record label is thinking about this for you know, like rock's first 10 or 15 years. So it becomes a situation where they have to invent new gear and new techniques in order to do it. You know, the Beatles' progression from Love Me, you know, from Please Please Me, Please Please Me to Sgt. Pepper, for example, is a pretty massive one sonically. But the truth of the matter is that that's mostly a lot of the same gear. They've got a little bit more ability to have extra tracks by Sgt. Pepper, but not much. And they got a Grammy for that, for the engineering, and they should have, because it was, monumental what they did. But mostly what they had then, in order to figure out, they were using a lot of the same techniques they'd been using for the last several years. The difference with Sgt. Pepper is they did something that was unprecedented for the time. They had one of the best studios in the world, and they had, about over 6 months to do it instead of a week. That was the difference, because the kind of gear and the kind of rooms that existed at the time, if you were, a pro jazz combo, if you were a professional orchestra, you could go in and out in a day or two, you're done. But for pop music and electronic music, as it progressed, it can't work that way, because if you look at the volume of a really loud drum kit and a loud distorted guitar and electric bass and keyboards, and then you think about a human voice, how is that ever going to, naturally acoustically balance? It can't. What's the likelihood of all those sounds at full bore overwhelming a room? Pretty damn high. So you're going to have to create new techniques, new gears, new studios, new rooms, new acoustics, new baffling systems, new isolation booths to deal with that. No one had that before. In late 1950s, early 1960s, what's an isolation booth? So when you got when you got a band like Cream coming in or something like that, the most they've got is some baffles between everything. You compare that to a recording from the 80s or something like that. Yeah, it sounds, in some ways, it's great music, but it's in some ways, technically, it sounds archaic, because there's just, actually, the truth of the matter is, the gear is great. It's just that you're hearing nothing but mic bleed. By the time you're 20, 30 years down the road, and every instrument's recorded at a different time off of scratch tracks, and everybody's in an ISO booth and everything like that, you can make everything clean as a whistle.
Yeah.
So that it's not so much that the gear got better. In a lot of ways, the gear got worse. The gear's only recently gotten, better. I mean, God, with the exception of a few of the best of the best of the best boards and everything like that, man, in the 1970s, the first generation of IC, integrated circuit chips and everything, like boards that were based on those designs, oh my God, compared to the stuff from the 50s and 60s, not in the same universe. That stuff was dreadful. But the very best pro boards aren't like that anymore. They're discrete, they're class A. They went back to the best of the old, put in the better new parts and everything like that. And now, these days, if you got the budget, you got the best of both worlds. But it took a lot of time to people recognize that before we made a good turn, for a while we made a bad turn. It was a Hobson's choice of I need to be able to afford, 24 channels and fit this in my booth. But I only have this much money. So people were willing to take the fidelity of a $200 receiver. But it's still a multi-$1,000 board, because I've got multiple channels of all this.
I really, really like that, because I think that if there's an overarching theme to many of the shows that I've done, it encapsulates that very idea that what we did, we thought was a progression of sound quality. But ultimately, when we're honest with each other and we look at what was produced, I think it's fairly fair to say that we did a fair amount of backsliding for maybe a couple of decades. I don't know. I'm not trying to be too hard. Look, these people worked really hard to make the best sounds that they wanted to. I'm just talking in very general brushstrokes here, folks, that we kind of lost a little, maybe in the 80s, maybe I think you're saying as early as the 70s. But for sure, when the CD came out and digital was at its infancy, things didn't come out so awesome. But it was preached. The messaging, again, back to the marketing, the messaging was absolutely, this is an evolution. This is the next step. But I think maybe you're right. The reality was
pretty much early to mid 1980s and everything like that. And of course, there were three corporations that were involved in the original patents for disseminating digital audio and the compact disc. And Philips, I think, marketing was the ones that termed the coin "perfect sound forever." And and my joke for the next 3 decades was, wow, every year that perfect sound seems to be getting more perfect.
But I'll get off my podium now. I feel like we just somehow fell into the thralls of a forum theatrics there. But not an untrue statement and a very acute observation, I think, from a very broad standpoint, at least from the data I have to look at. And again, great things were made. I will never say that there isn't great music being made today. And it can be made easier. And it can be made amazing for cheap. I mean, you don't even have to play an instrument anymore. And I think that's something a lot of people don't realize. Like unfortunately, I've talked to many producers who pride themselves on the fact that they don't play an instrument. Again, rubs me the same way as it does when you use chords. Well,
but they do play an instrument. You know, like dealing with samples, dealing with your laptop, that's an instrument.
Yeah.
What device do you need in order to produce the music? You know, like these are, you know, like whether it's my drums and a percussion instrument or something like that, whether it's a stringed instrument or something like that, it's it's some sort of mechanical device that you put through. Now, you know, I mean, obviously, given my age and given my artistic proclivities, yeah, I've got my biases too. But I have to be intellectually fair. They're all instruments.
And like I was saying, you can construct a songwriting is kind of a separate beast than that too. A good song, if you can write a good song, doesn't necessarily mean you're a great musician. And a lot of great musicians can't write songs. So separate things too on that regard.
Different art forms, yeah, and great art forms, and ones that you require, you know, like a combination of talent and skill, dedication, and a lot of work. You know, like very few people, you know, the same way that you don't sound tremendous on any instrument, you know, the first day that you pick it up. You know, if you're super talented or something like that, maybe the learning curve's a little faster, still got to put in the work. And, you know, like writing music's the same. You know, like most of the best writers in the world, you know, like will all, you know, tell some similar story of like, you know, your first 100, you know, like songs or something like that, you're likely going to throw away and hope no one ever hears.
Oh, I got some on 4-track tape in my dad's basement. I don't think I want them to see the light of the day, but I keep them for some nostalgic purposes.
Exactly.
Garth, any other kind of comments, advice about hum that we got here before we end the show?
It just takes patience. You know, like ground strapping via an RCA to RCA to, you know, like floating grounds, whether it's done, you know, like on a balanced cable with pin 1, or sometimes, you know, like particularly pro audio companies often have RCAs that have like a floating ground 1-pin switch, whether you're, you know, dealing with that, whether you're, you know, like again, cheater plugs on the AC and so forth. All these things that you try just become one variable at a time, document everything. You know, like these things are solvable. It's not black science. You know, like it's not witchcraft. You will figure it out. But that's something that you have to be very methodical, very careful, and you try to do, like as in science, one variable at a time. You start making wholesale changes of just like, I'm frustrated. I'm, you know, like I didn't have this problem, you know, like with my last preamplifier. I put in this new preamp. Oh, I figured out that preamp's no good. No, it's not that it's no good. It's just that it's got a different type of circuitry that's more sensitive to this. That preamp that hummed might be better if you gave it the opportunity to work, but we just need to figure out the ground loop. Another thing that you'll get to is sort of like, you know, like, I don't understand this, Garth, because, you know, like I only have that ground loop appear between, let's say, 7 p.m. to the time I go to bed every night, and I don't have it in the afternoon. You know, like there's ghosts in my home. No, there's not ghosts in your home. Get a voltmeter. You know, like voltmeter, yeah. Measure your voltage, you know, like all of a sudden, you know, like in the evening time or something like that, maybe, you know, like the voltage because of, you know, like more or less use or something like that of appliances and everything like that in your neighborhood, you know, the voltage is going up and going down. You know, like go ahead and like measure it one night for me. You're right. Yeah, it changes like about, you know, 3-4 volts. Well, so the thing is that you're right on. You've had a problem at all times of the day. Like I was mentioning earlier, you could measure this with an oscilloscope, but it's low enough that it's below the breakthrough point of disturbing you. But when it gets high enough, it's breaking through and it's bad. And the thing is that difference or that differential is getting worse when, you know, like that voltage goes up and goes down. It's not black magic, it's science, but it's understanding holistically the whole thing as it really works together. Another thing that we didn't talk about with hum there's always like a million different things you could talk about. But when you have a fairly big, ambitious system where I've got amplifiers on one side of the room, or I got powered subwoofers on one side of the room, or I got, like powered rear speakers on one side of the room, and I've got my system over here, and I've got this thing plugged in over here, and this one's plugged into this wall outlet here, this is plugged into power conditioner over here, this is plugged into a power conditioner over here, it's plugged directly into the wall. But I wouldn't imagine that I was going to have any hum, because after all, I plugged most of my components into this magic box that's called a power conditioner or regenerator, so that's going to take care of everything wrong. Because the thing is that, again, it's the physics of this. Not only do each one of those outlets that the entire system is plugged into need to be a dedicated line, meaning that it doesn't share line, neutral, or ground with anything else. They're all discrete runs that are going straight back to your, like wall panel or your sub panel. But the other thing is that ideally they should be on the same phase. Now, what do I mean by the same phase? Well, if it's in a studio or an office, it's probably 3-phase. And so you have 2 opportunities to get this wrong. You need to basically trace out with your wiring diagram or your electrician, or through a lot of measurements, to make sure that and find out that everything that you're plugging in is on the same phase or wired that way. And an electrician can make sure that that's been done, or rearrange a couple of things at the panel. They don't have to run new wires or anything like that, so you're not going to have a problem. And electricians don't always understand this, because they're only looking at electrical code. They're looking to make sure that nothing sets on fire and no one gets electrocuted. That's it. They're done. And they've been taught that if people have big appliances, I want to put a little on this phase, and then a little on this one, and then a little on this one, and divide it up so that I don't have a problem. And that would be a good practice with appliances generally, but it's a horrible practice for pro audio, for broadcast, and for home audio video, because you're almost guaranteed hum when you do it that way, or at least your chances of getting it go up exponentially. And you're always going to have underlying ground currents that are giving you that masking effect that we don't want. We want this again. So there's that. On a typical North American home panel, by the way, if you take a look at your electrical panel and you're kind of curious, well, I wonder if, because I am plugging in this system to 2 or 3 different outlets around the room. So if I look at this, I wonder if these are all on the same phase. How do I know that? Well, you could ask your electrician, but short of like bringing them out there, and sometimes, like their answer, depending on how knowledgeable they are about this, can be sketchy. The thing that I know is true to be 99% of the time is that people tend to follow codes and follow certain patterns. So let's say we've got a typical electrical panel, and it's got maybe 2 columns of 120 volt breakers. So you've got for 120, you've got 240 volts coming in, and then that's broken out into 220 volt sections, called L1 and L2. Now, the way this is done, and so we would want everything in our system to be either entirely on L1 or entirely on L2, not a combination of both. How do we determine this? Well, typically on most breakers, when we talk about the breakers that aren't for 240, but that are exclusively for 120, whether they're 10 amp, 15 amp, 30 amp, 20 amp, whatever, the very first one is likely L1. Immediately under it, L2. Immediately under that, L1, and so forth. And then when you get to the bottom of the first column, it repeats at the top of the second column. So if you, have things, taped or labeled, or you've turned things off to kind of figure out what's what, and you're on, let's say, 3 different discrete, breakers going back to the breaker panel, and they're all 3 grouped together, they are not all on the same phase, because you've got 2 on one and 1 on another. Mm-hmm. You want all evens or all odds. And I've caught a lot of electricians that thought that they knew better than the client, even when the client asked for these all to be on the same phase. And I've caught them in a lie, because it's just sort of like, you don't, because the client's sort of like, oh, I don't understand all this stuff, and I don't have a voltmeter and everything like that. It's just like just go back to the meter. If everything's labeled and everything like that, all you need to know is your even and odds.
Any final comments for general noise as we pull back just a little bit from hum?
Whether you're dealing with the kind of cables that you're purchasing, the way that you're, kind of like dressing the cables to the extent that you can, keeping your AC cables away from your signal cables cables away from other signal cables, particularly if you've got very low output, signals versus higher output signals, digital cables versus analog cables. Sometimes it's just not going to be possible, but trying to avoid a rat's nest behind your system is always going to be a good idea. And if you're going to have power cables in proximity with any kind of a signal cable, to the extent that it can cross at 90 degrees is going to be better. And the further you can keep things away from each other, the better off you're going to be. That kind of stuff is just going to require some patience and some thought. Doesn't cost you any money. Like cable elevators and things like that for, like hardcore audiophiles and everything like that. All those things are great too. I do it. But, the thing is that a lot of this stuff is just about, just really, really good methodical practices, best practices. Now, obviously, like cables that have a really good noise dissipation system, like having, like things like, like power conditioners / regenerators, such as that we make with the Niagara series or PowerQuest, good idea too. But again, like my whole thing is about, I love my products. I believe in them. I'd be embarrassed. I wouldn't put them out and promote them if I didn't believe in them. But my whole thing first is just like understand what the problem is and everything like that, and don't put all your hope and faith and credit into I bought a magic box and I'm just going to install it and everything's going to be fine. A system, is about getting all the right parts together, putting the right, assemblage and practice together to get the best performance out of it. Before I would ever invest tens of thousands of dollars more in new loudspeakers because I'm not happy with the ones I've got now, I'd want to make damn sure that system's set up as good as it can be and those speakers were placed properly. Because the best speakers in the world placed poorly sound dreadful. I can't tell you at audio shows the amount of $1 million to $500,000 systems I've heard that were terrible. And it's just always comes down to, those rooms are awful, but you can do a lot in a supposedly bad room, but you got to put the care and feeding in. And a lot of that's about just, how diligent am I willing to be? How much hard work am I willing to put in? How careful and patient am I willing to be? Versus just, expecting I spent a lot, the stuff's got an exalted reputation, I'm done. Not true. The more performance you've got, the more work you've got ahead of you. It doesn't matter if you've got, one of the finest acoustic guitars in the world, or if you've got the finest, car that you could drive or something like that. Those things require more maintenance and more care, not less than a lower, model. That's just the way this works. To get the best out of things, you have to work a lot harder. There's other tangents I could go on to. Like, for example, one of the things that I'll see from time to time and gets into the whole thing with like noise and hum and everything like that is that in recent years, grounding boxes in the audiophile world have become kind of like popular. And they can really, really work well, but the amount of misinformation that's out about them is ridiculous. If it was just enough for people to just say like, hey, I tried this and on a couple of components it really worked well, I got no argument with that. And actually the Niagaras are essentially in part grounding boxes too. My next, versions even more so. I'm going further in that direction for certain components, but the amount of information out there that is, again, it's that thing that I talked about initially. Oh, all your hum problems are going to go away. All your noise problems are going to go away. And 10 other things are going to, you're just going to cure cancer because we've got this box. And it's just sort of like, come on. And then my other, issue is sort of like, your box of magic is not Earth. But anyway, that's, we're not going to go there now.
Garth Powell, thank you so much for coming on the show. Always a pleasure to have you on, my friend.
Brian, anytime. It was an absolute blast. I really appreciate you.
The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes PartTimeAudiophile.com, The Occasional Magazine, the PTA Newsletter, and AudioHead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. The Occasional Podcast and its original associated music is monitored, mixed, and mastered on the Focal Trio 6 BE Studio monitors. If you haven't already, please subscribe to The Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.